Hi guys, and welcome to our next video for Module 6 Acid and Base Reactions. Today we're looking at our applications of titrations, and these are really ones that come across in a variety of everyday situations. So our first one we're going to look at is the applications in industry. So where the industry actually use some of these acid and base principles within their industry. Also, the properties of acids and bases used in our ATSE people's knowledge of stings and so forth, and how they actually use them without necessarily calling them acids and bases, but using the same principles. And our last one that we're going to look at is the use of digital technology when we're talking about titrations. So the first one we're going to look at is in industry. So there are many fields that actually use titrations in the industry. So one of our main ones is usually in pharmaceutical industries. So that comes in under your healthcare, but even our environmental monitoring with water quality and so on, some forensic analysis, but also particularly in our food and beverage industry. So one of those industries is the wine industry. And they need to actually monitor the production of their alcohol during fermentation. They also need to look at their the acid content within their wines that they're producing. So they use a number of different types of technologies to be able to do this. So when we're looking at the production of alcohol, there they have to do a titration called a back titration to measure the alcohol content. But they also use gas chromatography, another type of, I suppose, chemical technique or technique that can be used to detect how much alcohol is actually produced during that fermentation process. We're going to look at infrared spectroscopy. We're going to look at this a little bit more in our final module, Module 8, and hopefully get an opportunity to go and try looking at those in person. But that again is another technology that they can actually use, and it's a much quicker and also more reliable method to measure that alcohol content. But the biggest issue that we have is the acid content in the wine, and this really contributes to its taste. So wine's actually made up of a variety of different acids, and in some of them more than 40 organic acids can be found, but usually we consider it the tartaric acid. And so when we measure the acid content, although it's made up of a variety of different acids, we tend to put it down just to tartaric acid there. And the way we can measure the amount of acid in wine is by a titration. So we could do this in class as a prac just to determine how much actual acid is in that wine. We can also do this with soft drink, and we can also do this with juices. So we will do one of these in class over the next week or so. And again, when we do this, we are going to use it with a strong base. Now, I'm mentioning a number of different techniques here, and these are some of those ones that can come up under digital probes as well. So you might want to put that information across into your notes on digital probes and so forth. Another kind of technique that many places are using now, more so than the manual, is the automated titrators, and they're common in most labs. And again, they're taking away a lot of that error that can be there. So in the pharmaceutical industry, obviously, chemical analysis is quite important there because we're dealing with health and tablets that people are going to take. And we're using this chemical analysis right from the beginning of the drug development all the way through to marketing the drug. We need to be certain of what's in that drug before we can actually put it out to market. So again, here acid-base titrations are used to measure the salicylic acid and benzoic acid content in those drugs before they go out. Again, another way that we can measure those is through spectroscopy. So there's a variety and number of types: infrared, atomic absorption, and mass spec. And we're going to again look at those in our module 8. But we also have chromatography as another technique, which is using, there's two different types, or well, there's actually three: thin layer, gas chromatography, and HPLC. We can look up those, what they are, a bit later. Now, the one you're more familiar with is our ATSE applications. And we've had a good exposure to some of those applications, and we've discussed those already in class. So while they didn't use the term acids and bases, their knowledge and their understanding of plants and other substances has really demonstrated their understanding while they may not have called them these terms. So we have actually had some chemists go and do some analysis after, and they've actually worked out the active ingredients in many of those Australian plants used as being acidic or basic. So for example, our sting treatment, which is one that wasn't necessarily covered in our talk, we can use many plants here to treat stings. And what plant they use depends on where they're located. But one of these was a chewed leaf of a hop bush, and if you put it on a stingray and stonefish stings and bound it up for about 8 days, it actually was found to help with the pain and all the drama with the stings there. And peanut tree was also used, so they placed those heated leaves onto our insect and marine stings. Now, many of our marine stings, if you go up to any of the beaches up north, they will have vinegar sitting there on the beaches to rinse the sting with, and in that case those stings are obviously basic, but some of our ant stings that we get are acidic. And so what we use then is something for us like a Stingose, which is a basic solution to help neutralize that sting. In this case, the ATSI people are using plants that have obviously got those properties. One of the other ones you saw and we looked at was ochre. Now the ochre we've got's a white ochre. There are a variety of different ochres, and the colour is often indicative of the type of metal that may be in it. So if it was that reddy colour, it was often iron. And they actually again did chemical analysis and worked out that the ochre was a hydroxide base. So with that, it's obviously basic, so iron hydroxide. It was the reddy ochre. The one we looked at was white. Now, they often will use those to cure diarrhea, even their stomach upsets or indigestion, and often our indigestion is caused due to an excess buildup of acid. So by taking an antacid, which we take, it has got the hydroxides in them. By us taking the ochre, it's doing the same thing. Now, the last part we're going to look at, we've already mentioned a few of the digital probes as part of this dot point earlier with the chromatography and the spectroscopy, but the main types of ways that we're using this is with our automatic titrators. So obviously the titration is done with a machine, reduces our error and so forth, but also our pH meters. At the moment we have been detecting the end point with the changing colour, and as many of you have stated before, you may miss that. With a pH probe, we can monitor the pH change throughout the course of the reaction, and we can then use that curve to determine when the equivalence point occurred. Two other types that I'm going to actually get you to do a little bit of research on and just write down how they work is our spectroscopy. So again, we talked about infrared, mass spectroscopy and so on, atomic absorption, and also chromatography, of which there were 3 different types. We'll discuss all of these a little bit more along the way, and see you tomorrow.